Find the exact value of sine inverse 5 over 13 plus tangent inverse 4 over 3. These are in fact angles. When we evaluate sine inverse of 5 over 13 and tangent inverse of 4 over 3, we get angles. So this is basically sine some angle, let's say A, okay, and this is another angle B. So sine A plus B, and we have the formula for sine A plus B, okay, which is not simply sine A plus sine B, okay, it's got more than that, which is sine A cosine B plus cosine A sine B. So let's use that here. Okay, so sine A plus B is sine A is sine inverse 5 over 13, sine A, cosine B is tangent inverse of 4 over 3, okay, plus, so we are here in this formula, plus cosine A is sine inverse 5 over 13, cosine A, sine B is tangent inverse of 4 over 3. Okay, now we need to evaluate what is sine of sine inverse. Okay, these are inverses to each other. Okay, we are lucky for this factor, and since 5 over 13 is positive and this is less than 1, so they simply cancel, their actions cancel. So we have 5 over 13 times cosine of tangent inverse 4 over 3. Now we need to take the help of a right triangle. So we're going to draw a right triangle based on tangent inverse 4 over 3. Okay, from there we find the value of cosine. And if you look at the last factor, sine tangent inverse, so these angles are same. So let's draw an angle based on tangent inverse 4 over 3. So on side, let's say let theta be that angle, tangent inverse of 4 over 3. This is same as tangent theta equals 4/3. Then this is same as tangent theta equals 4/3. Now based on this we can draw a right triangle, obviously on first quadrant. Tangent is opposite over adjacent, so 4/3, so 4/3, this is theta. Now A, B, C, we can find the unknown side C. A square plus B square equals C square, so that's 3 square plus 4 square equals C square. That's 9 plus 16, 25 equals C square. That means C equals 5, so this is 5. Now we have all three sides. Then we can find cosine of theta, because we said this theta, and cosine of theta is adjacent over hypotenuse, so 3 over 5. So the whole thing is 3 over 5. Plus we need to work something similar to this for this factor, but for the last one, sine of this angle, which is theta, which we assume theta, sine theta, that can be found from this right triangle, same right triangle, that's opposite over hypotenuse, so 4 over 5. So the last factor is 4 over 5. Now we need to work on this. So let's assume another angle, beta be sine inverse of 5 over 13. So and then we can finish the problem here. Let beta be this angle. Okay, so we are saying beta, we said theta, we could have said A or B, doesn't matter. So let beta be sine inverse of 5 over 13, which is same as sine beta equals 5 over 13. Sine beta equals 5 over 13. Based on this we can draw a right triangle with angle beta. Sine is opposite over hypotenuse, so 5 over 13. Now we need to find the length of the adjacent, and this is A. We know that A square plus B square equals C square, so A square plus 25, 5 square is 25, equals 13 square, 169. Subtract 25 from both sides, A square equals 144. then a equals square root of 144 is 12. So a is 12. Okay, now we have all three sides, and this is cosine beta. Okay, and cosine beta is adjacent over hypotenuse, so 12 over 13. So this factor is 12 over 13. Now we multiply these two fractions, and same here, and add these two fractions. So when we multiply the bottoms and tops. In fact, we can cancel 5 from top and bottom, but look at the bottoms. 13 times 5 65, 13 times 5 65. So I would not, just 65 is the common denominator. 5 times 3 15, plus 12 times 4 48. Okay, if you cancel, then you have to multiply by 5 over 5 to make the same denominator. So now add these two numbers. 8 5 13 3 1 5 6, so 63 over 65. Okay, so the final answer is 63 over 65.